Welcome back. As you know, I am Eli, the computer guy, and this is Silicon Dojo. Silicon Dojo, authorityless, gatekeeperless, free to the end user, hands-on technology education here in Asheville, North Carolina that empowers our students to do whatever the hell it is that they want to do. Wrapping up this little beginning part here, we work for tips. We work for tips. Free to the end user is not actually free. All of this stuff costs money. My office costs money, the camera costs money, the computers cost money, the seats cost money. Everything costs money. My golly, you spend a lot of money educating people for free. So, anyways, there should be like a link down below for DonorBox or whatever other crowdfunding service that we're currently using. If you could drop some money in there, preferably reoccurring, that would be ever so lovely so that we can actually pay to educate people here in Asheville, North Carolina, and to be able to create these types of videos so that you can learn about this material wherever it is in the world that you are. So the final thing to talk about before we jump into the labs is the actual lab environment we have here at Silicon Dojo, so you can try to replicate this for when you're trying to follow along with these particular lessons, or if you're trying to create your own classroom. So we actually use Apple hardware. Now wait, before you go like, oh my golly, Eli, I can't afford Apple. Have you seen how much Apple costs? Yes, I have seen how much Apple costs. $133. Or what we actually use is $149. Our standard lab computer here at Silicon Dojo, and I'm saying this in 2023, just to be clear, that I didn't record this back in 2015 or something. In 2023, our standard lab computer is actually a 2012 MacBook Pro. Right? So this is now an 11-year-old Apple computer that, depending on the day, from backmarket.com, you can pick up for about $150. I think when I bought these, the prices go up and down. It's kind of an auction type environment. When I bought these, I think they only cost me about $130. Now, to be clear, when we buy the MacBook Pros, we then install Ubuntu onto the MacBook Pros, and it works like a champ, right? So these old MacBook Pros, they have the Intel processor on there, and you're able to install Ubuntu directly, natively onto the hardware, and everything works great. One of the reasons that I like the 2012 MacBook Pros is they have the built-in network card. So when you start dealing with like server lessons and that type of thing, and you're either not able to or you don't want to deal with a Wi-Fi connection, it actually has the built-in network card there. And the other valuable thing with Ubuntu is, at least for the 2012 MacBook Pros, the webcam, actually the driver works by default. You don't have to go in and do any kind of modifications or additional changes or anything like that. That can be very useful. So when we start doing projects like with OpenCV, like computer vision type projects, the fact that the webcam just works default when you install Ubuntu is a great thing. Basically, we buy these. You'll notice you get the normally like a 500 gig hard drive, like the old hard drives when you buy these MacBook Pros. What I do is I purchase a $30 SanDisk solid state drive. There are 256 gig solid state drives from SanDisk. Costs about $30. Basically, I put that in here, and they work great. So yeah, that's what we do. So we're using Ubuntu on here. We're using the MacBook Pro. We're putting the solid state drive in, and then for the IDE, we use something called VS Code, which I think basically everybody uses VS Code now. If you're thinking about using something like the MacBook Air, I will tell you, every single Intel Mac that I've tried to install Ubuntu onto, it works almost perfectly. The only issue you might run into is that whole webcam. So if you don't care about the webcam, if you don't care about having a hardwired network connection, again, you could get something like the MacBook Air. The 13-inch from 2012 is only $133. Dealing with the types of projects that we're dealing with here, these computers work absolutely fine. So this is something to be thinking about with your lab environment. Whatever you do with your lab environment, if you're going to be teaching this to other students or even for yourself, one of the things that I will tell you is, and what I tell my own students here, is I don't get paid to troubleshoot. Let's be honest, I barely get paid to teach at this point in time, but I definitely don't get paid to troubleshoot. So I have students that come into my classes, they have their own $2,000, $3,000 fancy MacBooks, and they say, well, I don't want to use your lab computer, I want to use my own computer. And then they sit there for half the class troubleshooting. Literally had this issue last night. We're doing a class on something called Tkinter framework. We had somebody with one of the brand new MacBooks, and curiously enough, so my Macs, I use Macs as my daily drivers, right? They're all updated and everything else with the normal Mac operating system. I have had zero issue with Tkinter. My student literally ended up having to uninstall Python, then install the Tkinter framework, then install Python back on top of it to get it to work. The important thing to be thinking about here is if you have people using different computers, especially if they're bringing their own computers in, you are going to spend so much time troubleshooting everybody's individual computer, it's going to be a pain in the butt. So whether you use MacBooks, like I recommend, or you go out and buy Lenovo or HP or whatever else, what I would say is come up with one standard build for your systems so that you don't have to worry about troubleshooting going into the future. So now that all that introductory stuff is out of the way, we can jump into introduction to Python. Now we do have this nice little workbook. Basically, this is what I'm just simply reading from here. I would recommend that you print this out. There should be a link for Silicon Dojo or GitHub somewhere around this video. Just print this out so that you can follow along at home, scribble out any kind of notes, that type of thing, as we go into learning Python. So Python is a programming language. So when you hear about programming languages, you'll hear about PHP, JavaScript, Java, C#, Swift, Objective-C, right? Different types of languages. The important thing to understand with computer languages is that computer languages are basically a lot like computer applications, computer software, right? So if you are going to be creating a term paper, you are probably going to use Microsoft Word, or you're going to use Google Docs or something like that. You're not going to use QuickBooks in order to write a term paper. Now, theoretically, you could use QuickBooks to write a term paper, but that would be a pain in the butt all the way around, right? Although you can do it, it's not really what it's built for. Again, if you're going to be doing an invoicing system, if you're going to try to, keep track of inventory and commissions and all that kind of stuff, you can do that in Excel. I do see some business owners do that garbage in Excel, but QuickBooks will make your life a hell of a lot easier. The same thing is true with programming languages, right? JavaScript does specific things. When you're creating front-end interfaces for websites, you're generally going to be using JavaScript. C#, if you're going to be building things on what's called the Microsoft stack, you're going to be dealing with Active Directory, Exchange Server, that type of thing, you would use C#, right? Every language has a thing that it's kind of focused on. Python, what I like about Python is that basically it is the super glue for the modern IoT world. Again, I am an old school systems guy. Literally got my MCSE and NT 4.0 back in 2000. I still have my plastic card. 23 years ago, I got my MCSE in NT 4.0, and I like systems, servers talking to each other, sending data around, all of that kind of thing. That's one of the reasons that Silicon Dojo is really kind of focused on that IoT world, dealing with APIs, dealing with microprocessors, microcontrollers, dealing with Raspberry Pis, that type of thing. I'm very interested in how all these devices can communicate with each other and trigger responses and remote systems and all that kind of stuff. And that's what Python allows you to do very easily. I did a seminar, an introduction to Python before. And one of the reasons that I decided on Python for Silicon Dojo is you can create software for the back-end infrastructure with Python. You can create a graphical user interface with Python. You can actually create mobile apps with Python. Whether or not you really want to do that in the production environment is its own thing, but you can do it, especially for a learning environment. You can deal with databases. You can deal with APIs. You can deal with microcontrollers. The Pi Picos actually allow you to write code in something called MicroPython. If you want to build robots with Raspberry Pis, you can use Python in order to do that. So Python is just a great language for essentially super gluing the modern technology world world together. Whenever you're thinking about learning programming and technology, really, one of the big issues that you run into is many times you kind of have to jump in the middle before you understand what's going on. That can be a very difficult part for new people trying to learn technology. Is there's this idea like when you learn math when you're a kid, you learn 1 plus 1, and then you learn 2 plus 2, and then you learn 4 plus 4, right? That's how you learn it as a kid. And somewhere along the way, you learn calculus, supposedly, if you get that far, right? You go 1, 2, 3. In the technology world, it doesn't really work that way. Basically, in the technology world, they just kind of dump you into geometry, and then you got to figure out the basic math and the more complicated math as you go. So this is an important thing to understand, especially with the class today. If you're new to programming languages and Python, is we're going to be jumping into the middle, where this is going to be basically what's called a back-end language. What I'm showing you today is what Python does, but this isn't normally how you interact with Python. So again, there's something called tkinter, which is a GUI framework, allows you to create graphical user interfaces. So with that, you get text boxes, you get drop-down boxes, you get buttons, right? So you put something in a text box, you hit a button, something happens, right? That's what you're normally used to. We're not doing that today. We're just looking at the basic code. We're just going to write some code. We are going to spit out some results, essentially in the command line. And that's what we have. It's important, though, because in order to create graphical user interfaces, you're going to actually have to know this basic level of coding. Then, once you get past the graphical user interface and the back-end code, then you get to things like the data stores and the underlying operating systems. So you can have Python, which will communicate to database systems. We'll be communicating with the operating system itself. We'll be communicating with APIs and other types of platforms. And those are their own entire world, right? So you can have front-end developers. All they do is create that front-end user experience that you're used to. You can have back-end developers. Back-end developers, essentially, they learn how to take information from the front end, send it to a data store, pull information from a data store, send it to the front end. They're kind of the middle people, right? And that's a job. That's an occupation you can have. Then you can have the data people, right? There's people that just do databases. They know something called SQL, structured query language, that type of thing. All they deal with is the data stores. And so these are all, these are different entire career fields you can go into. And so one of the problems, again, when you're going to be learning programming is it can be a little bit confusing because you've got to start to try to understand all these divergent fields in order to understand what you're currently doing. So just realize that can be a little bit confusing. Python, just so you know, is what's called an interpreted programming language. So this shouldn't be a big deal for most people in the modern world. What interpreted programming language means is that you actually install a piece of software onto your computer called an interpreter. You write your code in plain text, and then the interpreter, whenever you call that code, the interpreter reads that plain text and then basically turns that into a piece of software for you. Right? So you can have compiled programming languages. Compiled programming languages is where you take the plain text, you put it through a compiler, and that compiler actually comes out with an executable on the other side. Right? That is not Python. What Python is you have a plain text file. Every time that plain text file is called, you have an interpreter that reads that plain text file and then basically gives that output to the end user. Why it's important to understand the whole interpreter thing is that you actually have to have the Python interpreter installed onto your computer. So any interpreted programming language, you have to have the interpreter installed onto the computer. The good thing with Python is basically it's installed on all computers at this point in time. So whether you're dealing with Windows, whether you're dealing with Mac, whether you're dealing with Linux, they all should have the Python interpreter already installed. They may not have modules and frameworks that you also need to have your Python software work, but at least they'll have that basic interpreter. You'll hear me talk about frameworks. Frameworks are basically additional programming libraries that contain functions and contain a lot of things that allow you to extend the initial Python programming language. So you hear me talk about Django, right? So one of the things that you'll hear is that with Python, you're able to create web applications. So not only can you create a desktop application, but you can create a website with a database backend and the whole 9 yards. Generally, when you do that, you use the Django Django framework, Django, that is an additional package that you install onto your computer that gives you the functionality to allow you to create these web applications. There's also a Fast API framework for creating web applications. There's a Flask framework for creating web applications, but those are additional packages that get installed that then extend the ability of what Python allows you to do. Again, when I talk about creating a graphical user interface, a desktop application, we're using the tkinter framework here. Again, it's a framework that we install onto the Ubuntu computer, and once we do that, we are able to write code. We run the code, and we get a little box, with the text box and buttons and all of that kind of stuff. So that's an important thing to realize. Like sometimes you'll be sitting there and you'll hear you can do something with Python, and you're like, I don't understand how to do this with Python. And it's like, well, yes, it is with Python, but it's with Python and Django, or with Python and tkinter, or Python and one of these additional frameworks allows you to create that finished product that you're looking for. These frameworks may have to be installed. And so that's going to be an important thing for you to be thinking about when you go to deploy your Python software, is to make sure that not only is Python installed onto the computer you're going to be installing your software onto, but also that it has the proper frameworks. Just something to kind of keep in mind. Again, with a framework like with tkinter, so tkinter is built into Windows, tkinter is built into Mac, tkinter is not built into Ubuntu. Right? So you could create a tkinter GUI application with Python. You could deploy it to Mac and Windows, and it'll work as soon as people run it. But when you deploy it to Ubuntu, you have to install the tkinter framework in addition. So one of those things to kind of consider there. One of the big things with Python is the delimiter is white spaces. So basically what a delimiter is basically where a command ends. So the computer understands where a command ends. When one command ends and a new command begins, basically it's so the computer understands how to read all the text that you're dumping into it. Think about delimiters essentially like periods, right? So when you read a sentence, you see a period, and that's the end of that one sentence, and then you go on to the next sentence. Same thing as with delimiters. Now, with some programming languages, they use delimiters such as semicolons. So PHP uses the semicolon delimiter, and that's it. White spaces, more or less, do not matter in the PHP world. Why that can be an issue is you can literally have one line of code that goes from here to the other side of the planet. As long as the semicolons and everything is in there properly, that code will run perfectly, but be a complete pain in the butt to try to read. Or you can have something, there's something called minifying code. So with some software, especially with interpreted scripts, the more white space there is in the script, it can actually take a computer a little bit longer to run that script. So there's something called minifying, where you can run your script through this minifier and it will rip out all the white space. Well, one of the interesting things is it's kind of a way to obfuscate your code, or not really encrypt your code, but make it very difficult to read. So if you put your code, again, PHP code or JavaScript code, something like that, through a minification system, it will rip out all the white space, and then you'll just get this block of code, which will run. It will run perfectly. It's a pain in the ass to try to read, though, because all the additional white space has been ripped out. So when they were creating Python, one of the big things with Python is readability. The idea that not only should it run well, but somebody should be able to sit down and actually be able to read what the hell you wrote without losing their damn minds. So in the Python world, white space is a huge deal. So basically, when we go into the code, I'll show you this. When you do like if-else statements, when you do loops, you have to either tab or space in. You may have seen the show called Silicon Valley, and in the show called Silicon Valley, there was this scene where the one main guy was getting it on with the girl who was also a coder, and then they started getting into an argument about spaces versus tabs, and then everything went to hell because he was tabs and she was spaces, whatever else. The important thing to understand with that is when you're dealing with Python, you can either do spaces in, so one space in, two spaces in, or whatever, or you can do tabs in. You shouldn't be mixing spaces and tabs, though. So just kind of keep that in mind. It's like, so when you do an if-else statement, so if, blah, blah, and then you tab or you space, tab or use space, tab or use space. I'll show you that once we actually start taking a look at some code. All the Python code that you're going to be writing will end with the .py extension. So whenever you're dealing with these interpreted languages, you always end it with .js for JavaScript, .php for PHP. Basically, whenever you're creating Python code, you just end it with .py. An important thing to realize is that over the years there have been multiple versions of Python. So there was Python 2 and Python 3. The important thing to understand is that these are not interoperable. Python 2 code will not work with Python 3. Python 3 code will not work with Python 2. Python 2 at this point in time should be dead. Should be dead. Anybody that's actually in the technology world, you know how that goes. Python 2 code should have died in 2020. They stopped updating it after 2020 for security and all that kind of stuff. Unfortunately, it may still exist. Why this is going to be important for you is like if you're dealing with Ubuntu, especially with Ubuntu, they have the Python 2 interpreter and they have the Python 3 interpreter generally installed. If you type Python space and the Python script, many times that will try to trigger the Python 2 interpreter to run your script. So if you write in Python 3, which you're going to be doing, and you try to run it through the Python 2 interpreter, it's going to fail. So basically, whenever you're running the script, you'll do Python 3 space, whatever the script is, and therefore you should get the Python 3 interpreter and everything will work hunky-dory. This is an important thing to be thinking about if you go to like Amazon.com and they have some kind of bargain basement book on how to learn Python. Just make sure you're learning Python 3, not Python 2. Yeah, and that's basically kind of getting you in the mindset for the Python world. Now, the first thing that we may need to do when we start playing with Python is make sure we know what version of Python we're using, right? So if you freshly install a computer with the latest operating system and you update it properly, you'll get the latest Python version and you should be fine. So if you go to install a framework or you go to install a module, you shouldn't run into any issues. But right? You might be going out there and you may be dealing with some kind of legacy server that for some reason they kind of locked that thing down in about 2015 and you don't know what Python version is currently running on that particular system. And so you might run into some issues if you try to, install a framework or something onto it. So the first thing that we need to do is basically just take a look at the version of Python that we're going to be using. So for that, we're dealing with Ubuntu here. I have the terminal link basically on the sidebar. If you don't have the terminal link on the sidebar, you can click the All Applications down here, and the terminal link will be basically in the All Applications area. Since it's on the sidebar, it's not there. We're going to click on this, and we get our nice little terminal. From here, all we're going to do is we're going to type in Python 3. So again, we're in the Ubuntu world. So we do Python 3 for that Python 3 interpreter, version, and then we get our version number. So we are currently using Python 3.10.6, which I think is the latest, or at least the latest enough for us. So again, for the most part, most of the classes, most of the labs that we're going to be doing, this probably will not matter, but it might matter, right? If you go to write code, you verify that the code looks properly, everything looks fine, but it's not running for some reason, make sure, again, with whatever framework you're using, see what version of Python it requires. Just take a look at what the version of Python you're running is, and this might be the issue. Again, this is why here at Silicon Dojo, we have one standard build for lab computers so that everybody is on the same darn version of Python. I don't have to worry about Sue being on version 3.8 and Timmy being on version 3.11 and Fred being on version 3.7, and then they're having all kinds of weird issues. And not only am I then having to look and make sure their code is right, but then I have to look to make sure their system is proper. Again, I am barely paid to teach you people. I'm sure as hell not paid to troubleshoot your systems. So again, this is another reason why just having a lab setup makes a lot of sense. So now we're going to start doing a little tippy-tap typing, right? The first thing we're going to look at is this lesson number 2, and we're going to be taking a look at the Python shell. So the Python shell is really cool. It's a really awesome piece of functionality for Python that can also, wait for it, be an utter pain in the ass if you are a new user, right? So one of the issues that you have some people run into is they're sitting there and it's like they're thinking about, what script they're gonna run, and so they type in Python 3 and they're like, oh, what's the script called? What's the script called? And they're not thinking about it and they just hit enter, and all of a sudden they get this, and you'll notice, right? You go from this command line to this command line. Then they're like, oh, that's weird. What's the name of that file? ls space hyphen l. Whoa, wait, what the hell is this? cd. What the hell is this? This is the Python shell. So you can actually go into the Python interpreter and you can start running Python commands to interact with the system, but you're now in the Python shell. You're no longer in the Linux shell. So kind of think about this like with the MySQL shell, right? So if you're used to SQL databases, you type in MySQL, basically you log into MySQL, and then you're in the MySQL console. Basically, think of this as the same thing. Is you're now essentially in that Python shell. You're out of the Linux world. That can be a pain in the butt. And if you hit enter, it doesn't do anything. If you hit escape, it doesn't do anything. If you can hit Control C, it gives you a keyboard interrupt, and your life's about to get miserable. So what you do is you type in exit, open parentheses, close parentheses, enter. Yay! Oops. I don't know if you can see that here, but basically, you now get the you now get the Linux command prompt. So that's an important thing. So you can either do Control D or you can do exit parenthesis, and that will get you out of the Python shell, which is probably the most important lesson for you today. Let's see. Let me just clear this. And let's go into the Python shell again and just kind of give you an idea of what this looks like. So again, in the Python shell, you do Python 3. Then from here, what I'm going to do is I'm going to create a variable and I'm going to assign a value to the variable, just like I would in a normal Python script. So I'm going to create a variable called message. We're going to make it equal to hello world, because that's what we always do. Again, just follow along. On the lab here, we're going to hit enter. And so now you see you don't get any errors or anything. So that means we've assigned hello world to message. And then what we can simply do is we can do print, and then we can do message. So this will print out the value that's stored in the message variable, and it prints out hello world. Yay! And then we're going to hit exit. Exit. And we're going to get out of there. So this can be very useful if you're doing system administration tasks. Let's say you're going to search for files, or you need to move files en masse, or you need to do some kind of like administrative task like that. Going into the Python shell can be very useful. But if you're watching this class, that is way the hell over your head. So just remember, exit, parenthesis, open parenthesis, close parenthesis, and get the hell out of the Python shell. So the next thing that we're going to talk about is pip, but we're only going to kind of talk about this. We're going to go over this at a very cursory level, and we'll go into this in classes in the future. I'm simply talking about pip right now, just so that you know that it exists. So when you start doing some Google searches and you see pip, you know what the hell they're talking about, right? So a big thing with Python is basically that you're able to extend Python and you're able to add functionality to Python. One of the weird issues with Python is Python actually is like a core language, is relatively simple, and to get much additional functionality, you actually have to install packages into Python to get that additional functionality. Even with arrays, it's weird. Python actually doesn't have arrays as a standard data type when you create Python. They have what are called lists and dictionaries. We'll talk about later, but the array that you're used to, right? A normal array or a keyed index array or whatever else. that's actually not part of the basic Python that you're going to be using. You actually have to install a module called NumPy in order to be able to get arrays. So a big thing to understand in the Python world, again, is not only the basic Python language, but and how to install packages in order to get additional functionality. So if you want to do computer vision with Python, you have to install the OpenCV package, and that will give you all kinds of computer vision functionality, that type of thing. So when you're going to be installing packages, you're generally going to be using something called pip, the package installer program, I think it's called, package installer program. I don't know. It's called pip. And what pip allows you to do is it allows you to install packages and also allows you to see what packages are already installed on your particular system to verify that you're actually able to do whatever it is that you're trying to do. In the Ubuntu world, use something called pip3. So you do actually have to install pip onto Ubuntu. Again, another weird thing with Ubuntu, you have to install pip, but we can type in pip3 and version, and this will tell us what version of pip we're currently using. So we're using 22.02. That's the current version of pip that we're using. That might come up every once in a while. An important thing to take a look at, though, is what packages are installed onto your computer. So if we do pip3 list, this will actually this will tell us all of the packages that are installed. So again, if you're trying to do some kind of computer vision project or something else, you can come through and you can actually see if OpenCV is already installed onto this particular system or not, right? If you do need to install a particular package, you do pip3 install and then OpenCV or whatever package it is, and that's basically all you have to do to install the package. With pip, it's a lot like Linux, where there's a repository up on the web, so you do have to be connected to the internet. It goes to that repository and then pulls down whatever package you're looking for, it auto installs, and away you go. So just like you would install Samba server onto a Linux box or Apache or Nginx or whatever else, basically instead of using apt install, we would use pip3 install for the Python world. Now, I will tell you, be very careful about misspelling packages. So there are some hackers out there. This is going to shock you. You're going to be like, what, Eli? No, I can't believe you're saying it. But there are some hackers out there. And one of the things with hackers is they're always trying to figure how to get into your system. And not just your system, but how can they get into an enterprise system or a government system or a military system, right? How can they get their malware in there? So one of the things they've realized is if they create a package name that's a lot like a standard package but slightly off, they can actually put their malware package up into the repository. You misspell the package name, so instead of OpenCV, you do OpenCB, because B is right by V. You download OpenCB, and all of a sudden you installed some kind of Python package that will copy everything off of your server and FTP it off to the hackers somewhere. So that is something to be very careful about. Again, when I talk about things like lab computers, I recommend for all of my students, they buy a lab computer for doing projects so that they don't accidentally install malware into their computer that they do banking and email and everything else off of, because this is a real thing. Go out there, do a Google search on Ars Technica or other things. There are so many articles right now about these Python packages that are out there that have a slight misspelling to them. People install them onto a server on the enterprise environment and everything goes to hell. So anyways, that's just a bit of a basic idea of pip. That's all we're going to be talking about with pip today. We will be talking about pip in further classes going in the future. I just kind of want to give you an idea of what pip is and why it matters. So now we get into actually writing some more Python code and creating our first Python scripts. The first thing that I want to show you, though, is normally when you're going to be running Python scripts, you're going to be running Python scripts from the command line, right? So this is the standard command line or terminal that you would have on a Mac or a Windows PC. Again, we can see where we are. And basically, when we call a Python script, we'll do Python 3. So this is Ubuntu, so we'll say Python 3, and then then whatever the script name is, right? The path to the script, for-modules.py. And so we are on lesson 4, and basically we want to run the script that you're about to write. All we do is hit enter, and then the script runs. This will make more sense to you actually after I show you the actual script, but it prints out 6, and it prints out 7, it prints out 2, and there's a time delay there, and then it goes back to the command prompt. So this is normally how you will run Python scripts. The cool thing though is we are using what is called VS Code as the IDE, the Integrated Development Environment, in order to be able to write Python scripts. And the cool thing is with VS Code is you can actually run the script and the output shows up in the terminal down here, right? So let me just clear the terminal. I hit clear. So again, this is basically a terminal, just like you normally have. We have this this module script that I just ran. I can click on this run button here, and we can see 8, 9, 8, and 7 get printed out in the bottom. So as we continue on with this class today, I'm simply going to print out in the terminal down here, but just realize you could run this script from the command prompt, from the command line, and you will get the same type of output, right? This just makes our life a little bit easier. Now, the point of this particular lesson, that for lesson number 4, is I want to show you that to do almost any task, any kind of slightly complicated task in the Python world, you're going to have to import modules, right? So when you're dealing with something like PHP, you can simply call functions, and the functions are there. If you want to send an email, you call the mail function. If you want a random number, you call the rand function. If you want to do something else, you call a different function, right? And it's just simply there for you to use. If you want the program to pause, you simply use sleep or whatever it is in that particular programming language. The important thing to understand in the Python world is that would be too easy. That would be too easy. So what they do in the Python world is you actually have to import every module that you want to use or import in specific functions that you want to use in order to make your script work. The reason that this is useful is from a security standpoint. A hacker cannot compromise your script if your script simply doesn't have certain functionality, right? So with a PHP script, if a hacker is able to add some kind of mail functionality to your script somehow through an include or whatever else, then all of a sudden your server can get turned into a spam bot, right? The interesting thing with Python, right, is if that mail functionality, that mail function hasn't been added to the script, then even if a hacker is able to try to compromise what's going on, they're still not going to be able to use your Python script to create some kind of email bot, that type of deal. So that's one of the reasons why it's a very useful thing, but it can be a real pain in the butt because very simple functions such as random or such as sleep, basically being able to pause a script for a period of time, you actually have to import those modules or import that function into your script. So here we're going to import the module random. So this is going to give us random here, allow us to get random ints. And then we're going to from time import sleep. So when you're importing a module, there's a number of different ways to import modules. We'll go over this in further classes in Python. It gets a little overwhelming if you do try to explain it all at once, but I'm just going to show it you here. But one of the ways you can import an entire module is you import random. This is going to import the entire module, and then when we call a function in the module, we're going to call the module first, period, and then the function that we're looking for. So x equals random module, period, rand int, so random integer function, from 0 to 10. So this will give us a random number from 0 to 10. We're then going to print out, so print x. So x is going to equal this random number. We're going to print out x. We're then going to sleep. So sleep is pause for 1 second. Now here we have from time import sleep. So since we actually imported a specific function from time, we can directly call that function that we imported without saying the module that it's coming from. So if we said import time, then we'd have to do time.sleep whatever. Since we imported the specific function of sleep, we can simply call sleep itself, give it the 1 second, And that's what we have here. So this particular thing, we're not doing a loop. We're basically just doing copy paste. Copy paste is fine in the Silicon Dojo world. So we simply have x equals random period rand int 0 from 10, print that value, sleep for 1 second, get another random value, and get another random value. When we go down here and we actually hit the run, then we're going to see 8, 10, and 3, and you see that it paused there for that 1 second. So this kind of gives you an idea of kind of how modules work in the Python world. And don't worry, don't worry, you're going to continuously be interacting with the modules. So if you're a little confused now, don't worry, you'll get used to it. Now going to lesson 5, we get to the comments section. So comments are a big thing in the programming world. You can either use comments for documentation. That's a joke. Nobody documents their code. Document code? What does that mean, Eli? Anyways, you can either use comments to document code, we can pretend, or more importantly, why we generally use comments in the programming world, is basically we can turn off lines of code. So if we're creating functions, if we're doing something, we're getting some kind of weird kind of failure, we can use a comment to basically just comment out that line of code so that it no longer runs, so that we can try to troubleshoot what's going on. If we're going to comment a single line of code, we use the hash or the pound mark, right? So a hash or a pound, this will simply comment out a line of code, and the next line of code that you have, again, you get an error here because then this will actually try to run. So normally, when you see comments in the Python world, you'll see these little pound signs or these hash signs, and you'll see one after the other, after the other, after the other, after the other, after the other. Now, you can do a multi-line comment. Again, in the PHP world, you do / for a single line comment, / asterisk sign for a multi-line comment. In the Python world, you can actually do double quotation mark, double quotation mark, double quotation mark, opens a multi-line comment, and double quotation mark, double quotation mark, double quotation mark closes a multi-line comment. What I'm informed, what I've been told, is this isn't supposed to be legit. This is one of those weird things in the technology world where it works, and it's not really supposed to. Apparently, this just kind of makes the Python interpreter kind of lose its mind. So this isn't how you're technically supposed to do it, but it works like a champ if you need to. So if you got some kind of long function that you just need that to not run in your code for a little while to verify what's going on, you could use this multi-line code. So this can be very useful. Let's say you're creating an alert application that's going to send an email out every time an event, it's triggered by an event. Well, when you're sitting there and you're building that little module, that piece of functionality, you don't necessarily want an email to be sent every single time you trigger that script. So you're going to trigger the script over and over and over again as you're testing. You may test that script literally 100 times in 30 minutes. You don't want 100 emails being shot out every 30 minutes because then that's going to run you into problems. So what you might do is you may have like this 100-line script. You just simply comment out the little function that sends the email and make sure everything else is firing properly. When you verify everything else is firing properly, you uncomment out that email section, and that might be a way for you to go. So that's kind of one of the things to be thinking about with comments. And again, normally it's the hash or the pound. Seems to be what everybody's using. So now we get to lesson 6, and so we're talking about variables, types, printing, and concatenation. So an important thing to understand about the Python world is that Python does assign data types, right? So some programming languages assign data types. You actually have to set a data type. Other programming languages don't. The interesting thing with Python is you do not generally manually assign a data type, but Python will automatically assign a data type for you. So if you type out a string, if you type out text, it will auto-assign that a data type of string. If you type out a number, it will auto-assign that data type of int, right? Why this can be a bit of a pain in the butt is when you're what's called concatenating. So what concatenation is if you want to print something out on the screen, that would be a string, and basically you want to super glue, you want to tape two strings together. One of the issues you can run into is if you want to say like the temperature is colon, and then whatever the temperature number is, you can't concatenate a string with an int. So you would actually have to turn the int into a string so that you can super glue those two things together. So that's one of the things that can be a little bit confusing in the Python world, is that you do have data types, but they're auto-assigned, so it's really easy to kind of forget about it. All right. When we take a look at the 6.py script, the first thing that we're going to do is we're going to create a string. So string underscore var equals hello world. Because we always say hello world. It's just how the programming world is. Then we're going to create an int type. So num underscore var, we're simply going to say 66. Right? We're then going to print out the value of string var. So it'll print out hello world. And then we're going to print out the value of num var is going to be 66. Then down here, what I'm going to show you is when we have an int or a number value plus another number, we'll just get whatever that is added together. So print numvar plus 10, 66 plus 10 will be 76. That will get printed out. When we concatenate, so concatenate is basically supergluing two strings together. So we're going to print string underscore var plus. So a lot of concatenation, you use a plus, then you do double quotation marks, whatever text you want to put in there, close double quotation marks, and so this will print hello world, space hyphen, this is cool. So one of the ways you can concatenate is with a plus. Then what we're going to do down here is we're going to print out the string var, so hello world. You can also concatenate with a comma. So we can either do a plus or a comma. So we're going to use a comma. We're going to turn numvar, we're going to use a function called string, the str function. What this does is it turns one data type into another data type. So since this is an int data type, you cannot concatenate ints with strings. We're going to turn it into a string, so it'll print out hello world 66. Then we're going to do that down here, print string var comma, double quotation marks is a, close double quotation marks, comma, and then you use the type function. So the type function will be whatever, you'll look at the data type of the variable, and then we actually turn that into a string. And so this kind of shows you how you start nesting functions sometimes in Python. So you have the string var. We're going to put it into the type function. This will spit out the data type, but then we have to turn that into a string. So we put that through str, and so it'll say string var is a string. And then we have down here, so numvar is a number. We have to turn it into a string. So string numvar is a numvar type string, and so it should say int or something along those lines. So if we come here, let me increase the size of this. Okay, let me clear the screen, and so let's run through this, right? So string var equals hello world, numvar equals 66. Print string var, it printed out hello world. Print numvar, it printed out 66. We go here, print numvar plus 10, that printed out 76. Print string var plus this is cool, hello world, this is cool. Print string var, numvar turned into a string, says hello world, 66. Then we say print string var is a string var type string. So hello world is a class string. Print numvar turned into a string is a numvar, the data type of numvar turned into a string. 66 is a class int. right? So this kind of just gives you a bit of an idea of how variables work, how data types work, and how concatenation works in the Python world. So now we're going to talk about if-else statements. So if-else statements are basically the backbone of the programming world. If something is or isn't, do this, else, do something else. So you can have if-else statements or if, else if, else statements. So basically, if this is true or not true, do this. Else if this is true or not true, do this. Else if this is true or not true, do this. Else none of these things are true, do something else completely different, right? So basically that's what we have with this particular script here. This little 11 lines of script. We're going to be using our random int again, just to be able to get a dynamic number to play around with. What you're going to notice here is we're going to say from random import rand int. So before we simply imported random, and then whenever we called rand int, right, to get a random integer, we had to say random period rand int and whatever else. Well, that gets to be a bit verbose, and so since all I need is that rand int function, what I'm going to do is I'm going to say from random import rand int, and then I can simply call the rand int function without having to have random in the beginning. So here what we're going to do is we're then going to do random int equals rand int from 0 to 100. So we need a random integer and we want it from 0 to 100. Down here, we've actually commented out this line. So this is random int equals 1000. We're actually going to use this in a little bit to show you what kind of failure of the script looks like. But we currently have this commented out, so this is currently not true. Then we're going to come down to the if-else statements, right? If random int is less than 50. So when we say less than 50, that's not 50 or less, that's 49. 50 is not less than 50. 49 is less than 50. 49.99999, if it was a float or a decimal, is less than 50. But 50 is equal to 50. So here, if random int is less than 50, you do colon, and then we're going to print random int, comma, is under 50, right? So if it's under 50, we're going to print out what the random int is and that it's under 50. Elif, so basically else if, but it's ELIF, random int is greater than or equal to 50. So 50 and above, and random int is less than or equal to 100. So if it's between 50 and 100, print random int, comma, is under 100. Right? Else, so if it's something outside of this, right, for whatever reason, imagine you're getting values from a sensor, the values from the sensor, let's say it's a temperature sensor, the value is supposed to be from 0 degrees, let's say to 120 degrees, and you start getting readings of 1,000 for whatever reason, right? You might want that final else. Then we simply have print random int problem to say that there's an issue going on, right? Pretty simple. So when I go to actually run this script, I hit the little run button over there, and we can see 53 is under 100. 95 is under 100. 31 is under 50, right? And so that basically kind of gives you an idea of the if, elif, else statement. Now, if we go up here, let's uncomment out that random int is 1,000. Let's comment. So now random int equals 1,000. We're going to comment out this. So this is no longer true. Hit Control S. I'm just come down here and clear this. And now when I go run this, so it says 1,000 problem, right? So that's basically what an if, elif, else if, else statement looks like. So if whatever it is, less than, greater than, less than or equal to, greater than equal to, not equal to, blah, colon, and then whatever it is. Elif, you can also have, random int, whatever the conditional is here. And then you have this operator. So basically it can be and or. So if it's this and this, or this or that, you can have that. And then finally we have the else down here, and that's basically how the if-else statements work in the Python world. So now we get to lesson 8, and lesson 8 is lists. So again, if you're used to PHP or other programming languages, you might be used to arrays. Do remember in the Python world, what is built into Python are lists and dictionaries. What a list is basically it's a variable that has multiple values at different numbered indexes. So basically list at index 0 is Bob, at index 1 is Sue, at index 2 is Tim, and at index 3 is Fred, right? That is what a list is. A dictionary is where you actually have a named key. So you could have like name or age or something else. Name equals Bob, age equals 12, right? That kind of thing. But anyways, what we're talking about right now is lists, right? So we have a list. The list here equals, we open up with a square bracket, double quotation marks. So with strings is double quotation mark. Numbers, you don't have to use the double quotation mark. So we have Bob, comma, Sue, comma, Tim, comma, Fred. So this is our list. So then what we can do here is we're simply going to print list, and it's just going to print basically this out to show us what we're dealing with. One of the nice things in the Python world is you can simply print whatever the variable is on its own, and it will print out. And this will show you the variable type that you're dealing with. So again, like the PHP world, think about var dump. Sometimes you'll use something called var dump to dump out all of everything within a variable to understand what you're looking at. With Python, you can simply print whatever that variable is, and you can see if it's a list or a dictionary, an object, or whatever else. Then what we're going to do is we're going to append. We are going to add to this list. So we're going to add Tommy to the list. So list.append Tommy. And so then it'll be Bob, Sue, Tim, Fred, and Tommy. That gets added on. We're then going to print this out so we can see that Tommy was added on. List.remove. So to get rid of a value in a list, we're going to remove Sue. So then Sue will be removed, and we're going to print out what it currently looks like. Then we're going to list.sort. So we're going to alphabetically sort this list, and then we're going to print that out to see it be alphabetically sorted. Let me scroll this up a little bit. So we print out the list. Then we're going to do list.sort reverse. So reverse alphabetically sort the list, and then we're going to print it. Right? So that kind of gives us some of the basic ideas of how to deal with a list. So we can create a list, we can append, we can add a value to the list, we can remove, we can delete a value from the list, we can sort a list alphabetically, and then we can reverse sort a list, or reverse alphabetically, right? Then what we're going to do is we're going to come down here and we're going to do a for loop. So what a for X in list does, so for X in whatever list that you're dealing with, is for each index in the list do something. So for X in list, print X. So what this will do is it'll print Bob, it'll go print Bob, then it'll print Sue, then it'll print Tommy, so on and so forth. So basically it's going to loop through and print those values on different lines. So for X is how you step through a list in the Python world. And the final thing that we can do with a list is we can just create a really long string, like with concatenation. What if we want to add things together to a string? So with this, it's going to print out the value at each index point as it comes up. With what we're going to do down here is we're going to just create a long string of all the values. So string equals, double quotation marks, no space, nothing, close double quotation marks. So whenever you create a variable, you have to assign a value to that variable. So essentially here, we're assigning nothing. We're going to make it empty. For X in list, so for each index in the list, string is going to equal string. So we put this in parentheses, plus X, so what are the value, plus parentheses, double quotation, space, close double quotation. So it'll be like Bob, so it'll be, first it'll be nothing. So it'll be nothing plus Bob plus a space. Then it'll be Bob plus Sue, Bob space plus Sue plus space. Bob space Sue space Tommy space. And it'll step through, then it'll print out all of those values on one singular line. So we go through here and I hit the run button. So I hit the run button up here And so list equals Bob, Sue, Tim, and Fred, print list. And we have Bob, Sue, Tim, and Fred here. So we printed that out. Then we're going to append. We're going to add Tommy to that list. So we have Bob, Sue, Tim, Fred, and Tommy when we print out the list here. Then we're going to go down. We are going to remove Sue. So when we remove Sue and then we print the list, we now have Bob, Tim, Fred, and Tommy. Sue is no longer there. Then we're going to sort the list. So we'll alphabetically sort the list. Then we'll have Bob, Fred, Tim, and Tommy. So that's an alphabetical order. Then we're going to come here and we're going to reverse sort. So that's going to give us Tommy, Tim, Fred, and Bob in reverse order. And then we're going to come down here and we're going to have this for X loop. So for each index in the list, print out the value in the index. And so then it prints out Tommy, Tim, Fred, and Bob. So whenever you print and you don't do any concatenation or anything, it'll print out on a new line. You don't have to add a new line character in the Python world for that. And then finally here, where we're going to be creating one long string, so we just want to create one string, then, string equals nothing for X in list, string plus the value plus a space, keeps looping through. And so we see down here, it prints out Tommy, Tim, Fred, and Bob, all in one single line. You don't have any brackets, you don't have any commas, you don't have anything else, right? So this is a basic idea of how lists work in the Python world. So now let's go to lesson 9 and take a look at dictionaries. So dictionaries are kind of sort of like a named key array, again in PHP or another programming language, basically where you have multiple values within one variable, but the index has a name, not simply a number. Right? So here we're going to have dict. So our dictionary is going to equal open squiggly bracket and then the key name. So double quotation marks, we're going to call it name, close double quotation marks. Then we're going to do a colon. And so the value of the key name is going to be Bob. Then comma, key age, colon, is going to be 17. Size, key size is going to be a large. Then we're going to simply print out the dictionary, and essentially that's what we're going to see. Then what we can do, if we want to call a particular value from this dictionary, we can call that value with that named key, right? So I want to print out from dictionary whatever the value of name is, and that will print out Bob. If we want to add a value to this dictionary, it's very easy. All you do is you call a named key that does not currently exist. So currently we don't have grade up here. So we're going to have dictionary, dict, the key of grade, and we're simply going to make that 11. So it's going to assign the value 11 to grade, and it will simply add it to the dictionary on its own. You don't have to do anything else. We're then going to print out the dictionary, just so you can see that the grade is there. Then we can do dict.pop. So what pop does is it actually removes a key from your dictionary. So we're going to remove age. So that's going to go away. Then we're going to print that out. Then down here, basically, we're going to have that loop again. So for X in list, what we did before. But now we have both the name of the key and the value. So we might want to print both of those out. So what we can do here is for, this can be anything. So the first thing that you say is how the key is going to be called. So you're going to say for key, comma, value, in dict, period, items. So you add this items function, colon, and then you're going to print out key, and then comma, then double quotation marks, colon, space, double quotation marks, comma, and the value. So it'll print out the key, then it'll print out a colon, then it will print out the value. Down here, just to show you, you can call the key value whatever you want to call. You want to call it, it's for X, comma, Y in dict period items. So basically the same thing here. We're just calling it X and Y. Then we can simply print out X, comma y, and it will simply print out the named key and the value. So that's basically what's going on here with the dictionary. If I hit the run button up there, we have this run now, and so let's see here. So, okay, so dict equals name Bob, age 17, size large. If we take a look here, we then print this out, name Bob, age 17, size large. Then if we want to print out a single value from this dictionary, so we want to print out the value of name, right? We can see that Bob got printed out here. If we want to add grade as a key with a value of 11, we just simply add this here, we print it out, and we now see we have grade 11 here. Then if we want to remove, so we want to pop out, we want to remove age, we can then print out, and we can see that age has now been removed. So dict.pop age or whatever gets removed. Then if we scroll down here, we can see for key value in dict items, print key colon value. And so if we scroll down, we can see name colon Bob, size colon large, grade colon 11, right? And then if we just want to print out the values or call those values for x comma y in dict items, print xy, then we can see name, simply space Bob, size space large, grade space 11. And that's basically more or less how dictionaries work in the Python world. So now let's go to lesson 10 and take a look at while loops. So loops within the programming world is basically you continuously do something until you get to a breakpoint. So the for x in list or the for xy in dictionary, basically you will continuously loop until you get to the end of the list or you get to the end of the dictionary. You may want to be doing other things with math or whatever else and basically continuously do something until something occurs and then you want to break out of it, right? And so that's all we're dealing with when we're dealing with while loops. This particular script right here, we're going to import random again. So I'm just messing with you. I'm getting you used to dealing with modules. So before we said from random import randint. Here, we're going to do just import random. So when we call random, or when we call randint, it'll be random period randint. Right. Anyways, we're going to create x. We're going to have it be a value of 1. Y is going to be a random value. Then what we're going to do here is we're going to create a while loop. While x is less than 10 colon, tab in, print x, then x plus equals 1. So this is how you iterate. You add 1 to x. And so what will happen here is x will start at 1, then it'll print out 1, 2, 3, 4, 5, 6, 7, 8, 9. And while x is less than 10, so not 10, while it's less than 10, it'll keep printing. When it gets to 9, next time it goes up, it'll hit 10, it'll break out a loop, it won't print. So this just kind of shows you how that while loop looks. Then we're going to make x equal 1 again, so we reset x, because right now x equals 9. If I simply go to a new while loop and use x again, it will literally start at 9. So we reset x back to 1. While x is less than or equal to 10, basically do the same loop. This just shows you it'll go from 1 to 10 at this point. Less than 10, it hits 9. Less than or equal to 10, it'll hit 10. Just to show you how that works. And then to get a little dynamic stuff going on here, so we have x equals 1. While x is less than or equal to 10, print x, print the value. If x is equal, so if x equals y, right? So if this equals the random integer that's been created, print winner and break. If that doesn't happen, it's simply going to go to x plus equals 1, and it will continue. So basically, we'll get a random number here, before 5, 6, 7, whatever else. This is going to continuously loop through until it hits that random number, and then it's going to say winner. So if we run this script, this is what it's going to look like. So here we go here. So Okay, so this is the while script being called. Then for here, while x is less than 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it's done. Then it doesn't do anything else, right? So then we go here, while x is less than or equal to 10, print out. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So prints all the way to 10. And then down here, x equals 1. While x is less than or equal to 10, print x. If x equals the random number, print winner. So this kept printing out. So 1, 2, 3, 4, 5, 6. And then winner was 7. If I run this script again, we can see 1, 2, 3, 4. Winner was 5. Run again, 1, 2, 3, winner was 4, winner was 9, winner was 7, winner was 4, winner was 7, winner was 8, winner was 10, winner was 2. Right? So that kind of gives you an idea of while loops, and it also starts to show you, again, how you can start doing things like adding if statements into something like a while loop to just be able to print off if somebody's winner. Think about this, again, let's say you have some kind of lottery system. Let's say you have 10 students in a class, you have one t-shirt that you're going to give away, so you could do this random, like basically essentially loop through. And the seventh person, that's going to be the winner of the t-shirt, that type of deal. So anyways, that's the basic idea behind while loops. So now we get to lesson number 11, writing to files. So imagine, you have Python, you're pulling in information from an API, you're pulling in information from a database or from some kind of form where the user is inputting information, and you want to write that to a file. Maybe you want to write it to an HTML file, so be able to create a web page that's formatted as a web page, or to be able to write it to a file that's formatted more for an email or simply to get printed out or to be read in something like Word or a normal piece of word processing software. So here, basically, we have two examples. And with these two examples, I've shown two different types of formatting. And so this is an important thing to be thinking about with how is your text going to be read? What software are you going to be using, or is the user going to be using to read whatever it is that you're printing out? So HTML, right, hypertext markup language, uses markup tags in order to format text, right? So a P tag, a strong tag, right? H1 tags, H2 tags, those types of things, those are used in the HTML world so that when you go to a web page, it's formatted how it's supposed to look. The important thing to understand, though, is in a normal ASCII text editor, so Notepad or even Word or something like that, if you write in these tags, those tags are going to be there. That formatting doesn't matter to Notepad, Notepad++, or whatever else. What it does care about is ASCII text formatting, and so that's where when you do /T, so /T is a tab. So if you want to tab in the just ASCII text world, it's a /T. If you want to do next line in the ASCII text world, it's a /N. And so basically what we have here is this is printing out in ASCII text. This is printing out in HTML, just so you see how that looks different. Actually writing to a file is relatively easy. We're going to create a variable name, so we're simply going to create a variable name of file. We're going to open class.html. So in this directory, we're going to open a file called class.html, and we're going to write it with W. And so this is overwrite. So be careful when you start writing to files. W means overwrite. What that means is whatever was previously in the file will be deleted, and the new thing will be inputted. What we have down here is append. Append adds to the file. So be careful with that. So file open class.html, overwrite, so delete whatever was previously there. ASCII text is going to equal basically this string with ASCII formatting in there. We're then going to do file.write, the value of ASCII text, and then we're going to close the file. Make sure to close the file or you'll run into problems. We're then going to file equals open, the same file as append. So we're going to add to that file. HTML text is going to be open with a P tag. We're going to have a strong tag to make it bold, close the P tag, open P tag, so on and so forth. We're then going to write the HTML text to that file, and then we're going to close. So this is going to be ASCII text. That is going to be HTML text. When I run this, there's no actual output. If you look down here, there's nothing that comes out on the console because I didn't write anything here to come out on the console. We're then going to go to our File Explorer. We're then going to find class, so class.html. Now, why I call this .html is I can simply double click on this and my web browser will automatically open it. And so if we take a look at it, this is kind of interesting, right? Let me close this. So this text that is formatted for text viewers, see how that's all on one line? There's no tabs, there's no formatting there, that's all on one line. That's weird. But if we go down here and we look at the HTML, right? Since this is a web browser, the HTML, this is bold text that has been end P tag, open a new P tag, right? That's on multiple lines. Now, the important thing to look at, though, is if we come here and we look at source, so view page source, what we'll see is this is tab. This is tab, text that is, next line goes to the next line, formatted for next line text viewers. So a text reader would see this for this formatted text, and then when we take a look at the HTML formatted text, we see all the tags in here. So if we open this up with Notepad or whatever else, this is how this first line of text would be formatted, and this is how that second line of text would be formatted. So it's really important to be thinking about this when you're writing the files and really think about how people are going to be consuming whatever that output is, because you really think about how you have to format the text to make that work. But again, writing the files is relatively simple. W, so open the file name W, that overwrites, that deletes everything and then writes over top. A appends. What you decide to do is kind of up to you. Yippee! So now we're down to the final lesson of the day. So lesson number 12, reading from files. So not only can you write to files, but you can also read from files. One of the things I talked about before, right in the beginning of the class, is I talked about data stores, basically where you're going to be storing your data. So most of the time in the enterprise world, in a production environment, you're going to be storing your data into some kind of database system. You'll hear about Postgres, you'll hear about MySQL, you hear about Oracle, some kind of AWS solution, that type of deal. One of the interesting things, though, is that actually you can also store data into a basic text file, and you can store data as something called a CSV file. A CSV file is called a comma-separated value file, and it essentially allows you to create a poor man's database. So we go over here to this file called user.txt. Basically, I created the values for a couple of different users, Bob, comma 12, comma large. So name, age, shirt size. Sue, comma 22, comma small, Fred, comma 20, comma medium, Patty, comma 15, comma small, right? So imagine, again, if you just need a basic system, maybe you have 30 students in a class, you just need to track them relatively easily. Instead of coming up with a database system, maybe you could just add their information into something like this, a comma separated value file. Or let's say an Excel spreadsheet. So if you're using Excel, one of the things you can do is you can export to a comma separated value format. So it comes out as a text file that simply all the values are separated by commas. And then you could use Python to try to process that comma separated value file in order to do whatever it is that you're going to try to do. So for this is basically a pretty simple script here, 14 lines. So what we're going to do is we're going to create that file variable again. We're going to have it equal open user.txt, that file that we created, and we're going to open it as R. So read only. We're going to be reading. So before we had W, overwrite. We had append, add to. This is when we're simply going to be reading from the file. Then we're going to say file equals file. So this is kind of one of the interesting things you can do in the Python world is you can use the same variable name and then assign different things to that variable name. So file is opening the file here. Then we're going to use that. So file equals file dot read lines. So the file that we opened, period, read lines. What read lines does as a function is really nice, is it puts each line into the index of a list. So that list before that I showed you, so each one of those lines will be at a different index in the list, and then we can go through for x in file and print out that entire line, right? So then we're going to print out file. So we're just going to print out this list so you see what it looks like. Then we're going to, so for x in file, so for each index in the file, print out the value in the index. So that line is simply going to get printed out on the screen. Then what I'm showing you here is how you can do a query. What if I simply want to know, who is a large shirt, something like that. So the query is going to equal large. We're going to say for x in file, if query in x. So if large is in that line, right? Then what we're going to do here is we're going to split. So that comma separated value line, we can actually split that line into its own list. So we have the lines are in a list, then we can turn each individual line in that list into its own list. So we're going to split based off of the comma. So again, that comma separated value. Then we're going to print name x, so x at index 0, so that'll be the name. Age, x at index 1 will be the age, and shirt size, x at index 2 will be the shirt size. When I go to print this, we can see what this looks like then. Let me scroll this up. Okay, so file open, file read lines, print file. So this is what that list looks like. So we have Bob, 12, large, actually next line, comma. So that's one value, that's one index in the list. Then that's the next, between the commas here is the next, the index in the list, and then Fred, and so forth, right? Then what we're going to do here is for x in file, print x. So for each index in the file, print that index. So here, Bob, comma 12, comma large. Sue, comma 22, comma small. Fred, comma 20, medium. Patty, comma 15, small, right? So that prints that out. Then what we have down here is we have that query. What if I only want to see the people that have a large shirt size? So for x in file, if large is in x, I then want to split x, turn that into a list, and then print name, index of 0 in the list, age, index of 1 in the list, shirt size, index of 2. So we have name, Bob, age 12, shirt size, large. See how that works? If we want to do a query of small, because there's a couple people with smalls, Control S. Then we do that query. So name Sue, age 22, shirt size small. Name Patty, age 15, shirt size small. So this kind of gives you the idea of basically being able to read from files, and starts to give you the idea of how you would use something like a CSV file to store data for your Python script. So there you go. There's the introduction to Python hands-on class. So this is the class that we did here in Asheville, North Carolina a couple of weeks ago. And again, we're going to have more and more and more of these classes. One of the issues I do have to say is that if you're at home and you're just trying to study online, this may be a very difficult way of trying to learn how to code, because everything has to be right? You have to type everything properly, your computer has to work properly, the whole 9 yards. Literally, I was doing a class last night, again, on this framework called tkinter. And oh my golly, that was a pain. You know how they say that stupid people like to say, those who can do and those who can't teach. Oh my golly. Do you know what it's like to try to teach noobs how to code and not simply go back through your own code to see where you screwed up, but to go behind the code of 10 people in a class to try to figure out how they each individually screwed up that code? It is a complete and utter pain in the butt, right? Again, I had a student in the class. I had a student in the class who was actually he's been a coder for something like 15 years. He's a high-level muckety muck at some startup, and so he wanted to use his fancy ass new MacBook, right? He has one of these brand new $3,000 MacBooks. Why is he gonna use a $150, 11-year-old MacBook when he's got his fancy thing? And yeah, his fancy computer, the framework didn't work for some reason. He spent half the class troubleshooting it. So yeah, that's kind of how it is. As I'm doing these hands-on classes, I'm actually thinking about what I'm doing here. These are more guides for instructors. Again, if you're a scout leader, if you're some kind of youth minister, whatever, if you're something like that and you want to teach your people, your students, these concepts in technology, that's really how I see these types of videos and classes going forward. I'm really seeing this more as teaching the people that will teach this to their students because, yeah, you go through here and you use a semicolon instead of a colon. You screw up the spacing or whatever else. Again, it's a pain in the butt to figure out, to troubleshoot that, even as an experienced person looking behind a noob. You as a noob trying to figure out why something's not working, it can really suck. That's why there's a lot of people out there, they don't understand. They're like, Eli, you've done so much good on YouTube and doing online education. Why are you focused on in-person education now? And the reality is I've been doing online education since 2009, and I see the failings of online education. Again, online education is great. If you're already a tech professional, if you're already a coder and you just need some answers, if you know how to troubleshoot, if you know this other stuff, online education is amazing. Right? But if you're brand new, if you're 18 years old and you decided you're not going to waste your money on college, you're just going to do the online education thing, and then again, you try to follow along at home and something simple breaks, right? You're going to run into problems. As I've said many times in many of my videos, most people do not fail. To be clear, because a lot of people are like, "Oh, what if I fail?" I'm going to tell you, you're most likely not going to fail, right? Imagine this. You're out running, right? I've started running again. I just started doing half marathons. So you're out there running. You're running to a half marathon and you break your leg. That is failing to do a half marathon. To be clear, that is failing to do a half marathon. On the other hand, if you're out there and you're doing the half marathon, oh, and you're a little winded and you're a little tired. Oh, you got a little cramp. Oh, maybe I'm feeling, and then you stop, That is not failing. That is giving up. I'm not saying that you shouldn't give up, but again, there's a difference. Breaking your leg is failing. Being like, ooh, this is a little hard, that is giving up. What I see with most people in the technology world is they do not fail. If you're trying to learn Python and you literally stroke out, that's failing. Your brain just stopped working. You ain't gonna learn Python. Hopefully you remember the English language at that point. That's failure. If you're sitting there and you're trying to figure out Python and then it's just not working for you, if you stop, that's not failure. That's you giving up. And I think that's one of the big problems we see with a lot of people trying to get in the tech world is they just run into like just lots and lots of issues they can run into. And then they get frustrated and they're like, oh, it's not for me, and they give up. when in reality it might be some small stupid little problem that you're running into, right? So again, this is just something to kind of keep in mind. But yeah, we're going to keep doing these particular sessions. Again, we're going to do the T. Kenter framework class. That'll be coming out in a week or two in my particular timeline. And then my idea with Silicon Dojo is I'd like to get like 50. That might be a lot. That might be a lot. My goal that I might give up on is 50, 5-0. So we're going to have, again, we have this class, we have T. Kenter coming up, we have ChatGPT coming up, we're going to have OpenCV coming up, we're going to have database systems coming up, we're going to have interacting with the operating system, sub-process and OS modules coming up. And my idea is just to knock out, again, somewhere around 50 of these classes, and then these will just be modules that we can sit down and it's a replicatable system that we can go through and teach, the continuing generations on how to do this technology. Again, Python is a real programming language. You can get a real job doing Python, a good paying job. You can solve real problems with Python, and it just does so much. I find it to be a great programming language. So yeah, that's basically all I got to say. I do got to say though, do remember, free to the end user. I'll just remind people, free to the end user is not actually free. Donor box link down below. I'm just saying, there's a donor box link down there, or maybe it's up there, or maybe it's over there. Somewhere there's a donor box link. I'm just saying, if you want to click on it. Anyways, as always, I enjoyed teaching this particular class. I look forward to seeing you at the next one.